In this video, we're going to be looking at angles, some of the basic measurements of them and where they come from. So I think a good place to start with is just why do we even have 360 degrees in a circle? We typically think of things in terms of base 10, out of 100, right? 100% means full. So where are we getting this 360 from? Well, we can thank the ancient Babylonians for that because they were smart enough to use base 60. They realized even way back then that there were certain bases that just were much easier to work with and had a lot more power and just were more robust. We like to think in terms of base 10. A lot of people make the argument that it's because we have 10 fingers. But there are a lot of numbers that are actually way easier to work with and more divisible. And as you can see here, 10, for example, can be divided by 1, 2, 5, and 10. 60, on the other hand, can be divided by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60, right? So it's a much more robust number to work with. A lot more things can be done with it. One diagram that's helpful to understand this a little bit better that's also attributed to them in that time is this circle that's encompassed by these three equilateral triangles, where if we think of one of them as representing 60, right, and we know that to be true, that each of the angles in a equilateral triangle is 60 degrees, totaling to 180. Each of these then, around the middle, would be 360, right? And so that's where we get the idea. And again, you can see, if 60 is as powerful as it is, and having so many divisors, how much more so then is 360, right? And you can see all the different ways that we can break up a circle thanks to the fact that it is 360 and not 100. So even though it seems odd, it's actually very helpful. Just a quick minute to feature our sponsor today, water. The best way to hydrate since hydration became a thing. I was skeptical first when I started taking it, but I've really been enjoying the results, how it's made me feel, and I would highly suggest all of you try it as well. If you use the checkout code H2O4Life, you will be able to get a second bottle of water for the same price as the first one. So try water today. Okay, thank you. Back to the math here. Finding angle measurements. We have a couple of terminology things. First of all, adjacent. Adjacent just means next to each other. So here we have a 135-degree angle right next to a 45-degree angle. And you can see there's nothing in between, so we would say that these are adjacent, right? They share a side here. So that's adjacent, as opposed to vertical or opposite, where you have two lines intersecting, this angle over here and this angle over here, they're opposites. But we also recognize that by being opposite, they actually have to be the same value. So we have two 135-degree angles and two 45-degree angles. And again, when you add those all up, you get back to 360. That's an important thing to remember throughout these problems, is that always every intersection will always total to 360 degrees. So let's look at some examples. A little bit more terminology. Let me just get a good color here. Complementary and supplementary. So complementary just means that two angles that add up to 90 degrees. So in this example, if I have a 37-degree angle, I would need to figure out, well, how much more do I have to add to get to 90? And in this case, it would be 53 degrees. Okay? And so that would just be that problem. As opposed to having supplementary, where that adds up to 180. So instead of saying what plus what equals 90, you're saying what plus what equals 180. And so in this case, that would be 129 plus what? Plus, 61. No, that was right, sorry, 51 degrees. Okay? So that's what those two words mean. So if you see those in your textbooks, complementary means adding up to 90. Supplementary means adding up to 180. Okay? A little bit more terminology. We have a transversal. So if you have two parallel lines, if ever you see these little tick lines in your math books, it means that the two given lines are parallel. And that makes life a lot easier for us in determining the values of all of the fraction, or all the angles. So I have this pink transversal cutting through, and so what I realized though is that as this line cuts through here at this angle, it must also cut through this other blue line at the same angle. You could think about it like a knife cutting through a multi-layered cake at a certain angle. If the knife is straight, it must cut through all the layers at the same angle. Or as I mentioned in class before, if you can think of Superman flying through the multiple floors of a building, right? If he's going at a straight trajectory, he's going to cut through that floor the same angle he's going to cut through that floor, through all the floors. Whatever helps you to think about it. But the point is that this line, when it cuts through this blue line, it's going to cut through this blue line at the same angle because these lines are parallel and because the transversal is straight, okay? So because we know that, then we can look at, for example, this angle here and recognize that it's corresponding to this angle. And if that's the case, then we recognize that this also must be 42 degrees. Okay. And so we also see this other term here, alternative interior angles. That seems like kind of an odd expression, but when you break it down, it actually kind of makes sense. So if you think of these parallel lines as like a tube, right, where everything inside the tube is on the interior and everything out here is on the exterior, that's where we're getting this word interior. So we're talking about inside these two lines. Angles, obviously, because we're working with angles. Alternative, where's the alternative? Well, now we look at the transversal. And we're focusing on this angle. We recognize that it's on the alternate or the other side of this line as this angle. So we have this purple angle, we have this green angle. And if you think about it for a second, these must be equal, right? That's the cool thing about alternative interior angles is that this angle here must be the same value as this. I've referred to it in class as like the armpits of the letter Z, right? If that helps you to think about it. It's these two little pockets here and here, which must be the same value, okay? And so we recognize that, okay, well, if that's the same as this, then this also must be 42 degrees. And we didn't actually need the alternative interior angle truth to figure that out. We also could have just figured that out by looking at the fact that this purple angle is opposite this angle, right? And so, of course, these must also be the same. But then we want to continue. We say, okay, well, if those are both 42, what must this be? And there's two ways to look at it. You could think, well, these two angles added together must bring us up to 360. Or you could just cut the problem in half and just look at this piece and say, okay, this must add up with 42 to 180. And so you'd get 138. Okay, which would mean this also must be 138. This also must be 42. This must be 138. This must be 138. So you can see how even one piece of information kind of helps a domino effect to occur, where once you know one piece of information, you can figure out the others pretty quickly, so long as you know that these lines are parallel. Okay, so here's one final example for you to look at. Okay, get a new color. And you can pause the video for a second and try to figure it out. This one's a little bit trickier because I added a triangle here, and there's a little bit of extra knowledge that you would need to know, which is the fact that all triangles, the inner degrees must add up to 180 degrees. So the sum of this angle plus this angle plus this angle must be 180. So if that's the case, we see 99 plus 38, that's 137. And so then we say, how much do I have to add to get from 137 to 180? You'd have to add 43, okay? And so then we see this domino effect start to happen. So we say, okay, that must also be 43. Thinking about supplementary angles, what must this then be? 43 plus what? Well, it's actually kind of cool. It also is 137, right? So 137, 137, 43, 137, 137, and now we come to the final part. And so we see this one's actually been broken into two parts on us, but we know that the total of these two angles must equal what? They must equal 43. So I have this chunk already equaling 17, which means that this last bit must be 26. Okay? So So this is just a nice little overview of angles for you, talking about some of the terminology. There's a lot more terminology, but this covers a lot of the basics. Okay, so I hope that was helpful, and thank you for watching.